Hi everyone. Today we are going to start the next topic that is part of lecture 2, that is Ohm's law. According to Ohm's law, if you have a resistor, then in that resistor voltage is directly proportional to current. Suppose that if you have a resistor like this and you had the two ends of this resistor, the voltage, it will be directly proportional to the current passing through this resistor. Or you can say that if you plot IV characteristics of this for a linear resistor, I is directly proportional to V. When you remove this constant of proportionality, then V is equal to I into R, where R is what it is? V by I, and it is called resistance. So what is resistance? Resistance is it is the ability of a circuit element or ability of an element to resist the flow of current. The unit of resistance is ohms. You can write like this, or in terms of symbol, it is like this. Now, if you have a resistance, suppose that we am taking one example circuit. You have 1 kilo ohm resistance here. You have connected a voltage source of 5 volt in this circuit. It is a very simple circuit. Suppose that I is the current flowing in this circuit, and we are using passive sign convention. So according to this will be positive, this will be negative. And if I apply KVL in this circuit, then according to that, in a closed loop path, according to Kirchhoff voltage law, in a closed loop path, sum of voltage drop is equal to 0. So if I go in this closed loop path like this, in clockwise direction, then minus 5 volt plus I into 1k, that is 10 raised to power 3. This is equal to 0. And I will be what? I into 10 raised to power 3, this is equal to 5. And 5 divided by 10 raised to power 3. So this is 5 into 10 raised to power minus 3 ampere. So when you solve this, is 5 milliampere. Okay. So this is according to Kirchhoff voltage law. Now there is one concept that is called short circuit. So in this case, we say that when you can say that it is short circuit, then the resistance is 0. So when the resistance is 0, we say that it is short circuit. And there is another concept that is called open circuit. What do you mean by open circuit? When the resistance is infinite. Okay, when the resistance is infinite, we say open circuit. So in this case, when you have 0 resistance, so large amount of current will flow in the circuit. So corresponding to this, you have voltage is 0. Why? Because V is equal to I into R. When R is 0, then if in case of short circuit, R is 0, so I into 0 will leads to what? V equal to 0. In this case, if you see, I is what? V by R. So corresponding to the case when R is equal to infinite, your I will be what? V by infinite, that is 0. So in case of open circuit, if you see here, in case of open circuit, resistance is infinite and current is 0. In case of short circuit, resistance is zero and voltage is zero as a result of this. So these two concepts are used a lot when we are solving the circuit problems, or when you will study the Norton theorem and Thevenin's theorem. Now there is another parameter that is called conductance. Conductance is what? It is reciprocal of the resistance. So G is equals to what? 1 by R. And suppose that your V is I into R. If I invert them, so I is what? V by R. So you can write this in terms of G. The end of this is Siemens, or sometimes we also use the term mho. That is reciprocal of the resistance. When we solve the circuit, you will find that sometimes I writing the voltage source like this, plus minus 5 volt, 10 volt, whatever value. Sometimes you will also find that I am writing like this. So this is the symbol corresponding to a independent voltage source. For the current source, for the current independent source, we also use this symbol. This is the symbol for the current independent source. Okay. So there are other concept of voltage dependent voltage source, current dependent voltage source. So that I won't discuss here. Next topic is calculation of power. So power is what? Amount of work done per unit time. So this is dW by dt. And you can simplify this further. It is dW by dq into dq by dt. And this term, it represents what? Voltage. And this represents what? Current for a DC circuit. Now from Ohm's law, you can say that V is equal to I into R. So if this is equation number 1 and you put the value here, we can say that from equation 2 you put the value of V in equation 1. So it will be what? IR into I. So this will be what? I square R. Similarly, you can put a value of I. So P is what? V into I. And I is what? V into V by R. That is V square by R. So if you see, both current and voltage, they have a non-linear relation with the power. Okay. So here you say that power is directly proportional to square of the current, and power is directly proportional to square of the voltage. So you can say that there is a non-linear relationship between the current and the power, and voltage and the power in the circuits. Now generally when you are working with the circuits, you will find that if you are having a voltage source, so that this is a 5 volt voltage source, you have 1 kilo ohm resistance, then this voltage source, it will be supplying power to the circuit. Okay, so it will be supplying power to the circuit, and this resistor which is here, it will absorb that energy or power which is supplied by this voltage source. So those sources which are absorbing the power, we sometimes when we solve problems, then you will find that it will be indicated by the positive power. Okay. But those who are supplying energy or power to the circuit, they will be having negative. Means in terms of mathematical notations, we will get values in positive and negative. But power, if you see here, it is in terms of magnitude, if you go, it is dependent on the scale of the voltage and current. So it is a non-negative quantity. But from theoretical point of view, we can say that when you got the values like positive and negative, means that when you get a negative value, then it is supplying energy or power to the circuit. When you get a positive value, then it is absorbing power, okay, or energy from the source. This source can be voltage or it can be current source. I hope this concept is clear. Now there is another concept that is called active and passive components. In case of active components, these are those devices or components which supply power or energy to the circuit. So active components supply power or energy to the circuit. So here example is what? Your voltage source. So whenever you connect a battery to the circuit, it is supplying energy to the circuit. So it is active component. What are passive components? Passive components are those components which absorb power or energy from the source. Energy from the source. Example is your resistor, inductor, and capacitor. Okay. So example of passive components are your resistor, inductor, and capacitor. Inductors and capacitor, they store the energy temporarily, but they are not permanent store, means they cannot store the energy permanently. So that's why we count them, or we say that they are passive components. Now, if I move further, then when you connect the resistance or resistors in series, so I can say that when they connect the resistors in series, then how to calculate the equivalent resistance? Suppose that if I have a circuit where you are using resistor R1, R2, and R3. You have connected a voltage source of V volt in this circuit. I is the current which is flowing. So when you can say that resistor are in series, when the same current is flowing in the circuit. So in this case, same current is flowing. So these resistors are in series. Okay. Now in this case, if you see the voltage drop across them will be different. So if I denote voltage across R1 as V1, voltage across R2 as V2, voltage across R3 as V3, then I can say that I can apply here Kirchhoff voltage law. So when you apply KVL in this, you can say that V is what? It is summation of V1 plus V2 plus V3. And here V1 is what? I into R1. V2 is what? I into R2. Similarly, V3 is what? I into R3. Now, if I say that you are having a equivalent circuit where this combination is denoted by R equivalent and you are supplying the same voltage source in this circuit, same voltage source V is there and I is the current which is flowing here. So you can say that your V will be what? This is I into R equivalent. So you have this set of equation, means from V1, V2, three values here. So I say that this is equation 1, this is equation 2, this is equation 3. So when you put the value of V from equation 3 and V1, V2, V3 from equation 1, then you can say that this is what? I into R equivalent. This is I into R1 plus I into R2 plus I into R3. Okay. So in this case, you can take I common. So I into R equivalent is what? I R1 plus R2 plus R3. And R equivalent is what? R1 plus R2 plus R3. So in this manner, when you have resistors are in series, you can say that your equivalent resistance is what? It is simple addition of the resistances who are in series. Similarly, you can calculate the equivalent resistance when the resistors are in parallel. Okay, when the resistors are in parallel. So here also, suppose that I have three resistors. One is R1, another is R2, the third one is R3. All of them are in parallel. I is the current which is flowing from a voltage source of V, and the current in this branch I am assuming it is I1, in this it is I2, and in this branch this current is I3. So here you can apply at this node Kirchhoff current law. So apply KCL. You can say that your I is what? It is summation of I1 plus I2 plus I3. And if this V is the voltage here, then this voltage V, because as you know that when the resistors are in parallel, then the same voltage drop will be there, right? And according to Ohm's law, V is equal to what? I into R. So in this case, if you see here, you can say that for I1, this will be what? V by R1. For I2 current will be what? If you know the source of voltage, that is V, then it will be what? V by R2. And I3 will be what? V by R3. Similarly, just as the previous case, you can say that if the equivalent resistance of this is R equivalent, then you can denote that your, and I is the current. I can say I'm saying this thing. Suppose that if you have a voltage source of V and you have R equivalent here, I is this current, then you can say that I is what? It is V by R equivalent. So these are the set of equations. You put the values from, so this is equation 1, this is 2, and this is 3. So you put the value from equation 2 and 3 into equation 1. So when you put the value, you will find that I is what? V by R equivalent. So this is V by R equivalent. This is V by R1. This is V by R2. And this is V by R3. If you see on the left hand side and right hand side, V is common. So you can say that 1 by R equivalent is what? 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So here in this manner, you can simplify this further and you can calculate the value of R equivalent. Okay. Or if you want to simplify, you can say that 1 by R equivalent. This will be, you can take the LCM R1, R2, R3. This will be what? Here R2, R3. This will be what? R1, R2. And this will be what? Sorry, R1, R3. And this will be what? R1, R2. So from here you can say that R equivalent is what? R1 into R2 into R3 divided by R2 R3 plus R1 R3 into R1 R2. So this is how you can calculate the equivalent resistance when resistance are in parallel. Similarly, when the resistors are, suppose that if I take only two resistors, It's because this is very important. Means suppose that if you have two resistors, this is R1, this is R2. Okay, if someone asks you, you have to calculate the equivalent resistance of these two. So we can say that 1 by R equivalent is what? 1 by R1 plus 1 by R2. Okay, so R 1 by R equivalent will be what? You take the LCM, that is R1 into R2 or R2 into R1. Sorry. So this will be what? R2 into R1, and this will be R2 plus R1. Or you can say that R equivalent is what? R1 into R2 divided by R2. Okay. So this is R equivalent, right? Now, suppose that if you have two resistances in parallel, you have two resistances which are in parallel are 4 kilo ohm and 4 kilo ohm. If you want to calculate equivalent resistance, then you can use this formula directly. This is denoting your R1, this is denoting your R2. So it will be what? R1 into R2 divided by R1 plus R2. So here R1 is 4 into 4 divided by 4 plus 4. So this will be 16 divided by 8. So this is 2 kilo ohm. So from here we can say that your R equivalent will be what? 2 kilo ohm. Or we can means interpret from here that if you have two resistances which are equal, or if you have two resistances R and R, if they are in parallel, their equivalent resistance will be what? R into R divided by R plus R. That is R square divided by 2R. Or you can say that R by 2. Okay. So in this manner, we can calculate the equivalent resistances. Okay. Now I am taking one example here. Suppose that if you have a voltage source of 24 volt and you have, this is your 1 kilo ohm resistance. Here also you have 1 kilo ohm resistance. So you can have, suppose that you have 4 kilo ohm resistances. These are in parallel. There is another 4 kilo ohm resistance. Now you have to calculate the resistance between A and B terminal. That this is A, this is B, and you need to calculate the current in this circuit and power delivered by this source of 24 volt to this circuit. So in this case, first of all, we will calculate the equivalent resistance of these, right? So suppose that if I write the equivalent resistance is R equivalent in this case. So 1 by R equivalent is what? 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. And you can simply take LCM of 4. This is 1 plus 1 plus 1 plus 1. So 4 divided by 4. So it will be what? 1 kilo ohm. right? So sorry, it is 1 by 1. So I should write here. This is 1, and you can say that R equivalent will be what? 1 kilo ohm. Okay. Now we have calculated this part here. So your RAB will be what? This will be 1 kilo ohm. So you can say that 1 kilo ohm plus 1 kilo ohm plus 1 kilo ohm plus 1. This will be 4 kilo ohm. Okay. This will be 4 kilo ohm. Now, if I write the equivalent circuit of this, then you have a 24-volt source. I is the current in this circuit. This is A terminal. This is B terminal. And you have a resistance of 4 kilo ohm. So in this case, you can apply Kirchhoff voltage law in this. This is plus minus. This is current. So I'm using passive sign convention. So current is flowing in the clockwise direction. So I is the current which is flowing here. So you can say that if I apply Kirchhoff voltage law in this closed loop path, so it will be what? Minus 24 volt, 24 plus I into 4. This is equal to 0. For 4I is equal to 24. So I is what? 6 milliampere. So in this manner, we can calculate the current in the circuit, that is 6 milliampere. And what is the power which is delivered by this source? V into I. So V is what? 24 into I 6. So in terms of power, it will be what? 144 milliwatt. So the power which is delivered by this 24-volt source to the circuit is 144 milliwatt. Sorry. So now after this, I am covering another concept that is called voltage division. So according to voltage division rule, if you have resistors like this in series, we suppose that if you have two resistors R1 and R2, they are in series, then the voltage drop across them is V1 and V2. You are having some source of voltage, that is V. I is the current which is flowing in this circuit. So here V is what? V1 plus V2. And you can say that this will be what? I into R1 plus I into R2. This is your source voltage. Now in this circuit, suppose that if I ask you what is V1, V1 is what? I into R1. And I is what? You know from the previous explanations, it will be V by, if R equivalent is what here? If your two resistances are in series, R1 plus R2. So for this circuit, it will be what? V by R equivalent. If I calculate this equivalent resistance, it will be like this. Okay. So from here, you can say that your V1 is what? V by R equivalent into R1. Or you can say that the source voltage into the resistance across which you want to calculate the voltage drop divided by sum of the resistances. Similarly, if you can write that voltage across this is what? I into R2. It will be what? V divided by R1 plus R2 into R2. Okay. So this is, so in this we can use in cases where you directly want to calculate the voltage across the resistor R1 and R2. So in that case, you can directly use this formula. If you know the source voltage and restances, then you can directly use this formula to calculate voltage across the resistors when they are connected in series. There is another concept that is called current division rule. So current division rule is the concept which is used when you have resistors are in parallel. Suppose that if you have three resistors, I'm taking two resistors for simplicity here instead of three, and I is the source current here. Again, you have a voltage source V. I1 is the current in this branch. I2 is the current in this branch. So if we apply at this node KCL, then I is what? I1 plus I2. And I1 is what? From the earlier explanations, it is V by R1. I2 is what? Because same voltage drop will be there when resistors are in parallel. So it is given by this. Okay. Now V is what in this case? So if you calculate the equivalent resistances, then R equivalent is what in this case? When you have two resistances are in parallel, it will be R1 into R2 divided by R1 plus R2. Now, if I ask you what is I1? I1 is what? V by R1. Okay. And V, how you can calculate the V? V is what? I into R equivalent. So you can put the value of R equivalent here. So I into R1 R2 divided by R1 plus R2. So here I1 will be what? I into R1 R2 divided by R1 plus R2, and this will be divided by R1. So this will cancel out. So I into R2 divided by R1 plus R. Similarly, so from here, what you can say that when you have two resistances are in parallel, if you want to if you know the source current, then you can calculate the current in the individual branches. So the current in this branch where you have resistor R1 is what? I1 is what? Source current into resistance of the opposite branch divided by the resistance of sum of the resistances. Okay. Similarly, you can calculate the value of I of 2. So I of 2 will be what? It will be the source current into resistance of the opposite branch. So I am talking about this branch. What is the resistance of opposite branch? R1 divided by sum of the resistances, that is R1 plus R2. So this is called current division rule, where you can calculate the current in the branch if you know the source current and resistor values. Okay. So that's it for today. I'm stopping now.